In this video, I will talk about graphical means for summarizing data. So the title of Graphical Displays for summarizing data. Right? I will mainly talk about, there are many ways of different displaying data graphically, but in this video I will talk about three of them. One is known as the box plot, and the second one is known as the bar plot. The third one is known as the histogram. Right. So I'll start with the first one, which is the box plot. Right. The box plot, if you do that in R, it will look something like this, right? So I will explain what these are. Like the middle line here is the median of the data, and this line here is Q at 0.25, or the first quartile or quantile. And this line here is Q at 0.75, which is the third quartile or quantile. Right. Now, this is known as the lower adjacent. The way you compute it is as follows. In other words, the distance between this line and this line is equal to, so let me write this. The distance from this to this is equal to 1.5 multiplied by IQR. Remember what IQR is, the interquartile range, right? And similarly, if you go to the top, right, this is known as the upper adjacent, right? And the distance from this, to the distance from this line to this line is once again equal to 1.5 times IQR. And if any data points lie below this lower adjacent or above the upper adjacent, then they are considered to be outliers, right? So X, so suppose X is a data point. X is an outlier if the value for X is either greater than Q at 0.75 plus 1.5 times IQR, or if X is less than Q at 0.25 minus 1.5 times IQR. Alright, so if one of these conditions is true, then the data is said to be an outlier. Right? So either greater than this value, which is the value for the upper adjacent, right? Or less than this, which is the value for the lower adjacent, right? And the R command for doing this plot is simply the following. It's called box, B-O-X, plot, P-L-O-T, open bracket, X, close bracket. So X will contain the data, and this is the command you need to type in order to get a picture like this, right? Okay guys, The next graphical display I will talk about is the bar plot. So when you have qualitative data, like for example, if you have data on an election, the people who vote for one of these parties. So you have how many people voted for Conservative, how many voted for Labour, Liberal, UKIP or other parties, right? So a bar plot is very useful for displaying qualitative data, because this gives you like the party that you're voting for. So it says here that over 350 people voted for Conservative, over 300 voted for Labour, and so on, right? And so it's a means for displaying qualitative data. And once again, the R command for producing a bar plot is this, right? So there's a VAR PLOT, open bracket, X close bracket. That will produce something like this when you have the data, right? And the third way of displaying data is histogram, right? In this case, you have data on the lifetime of batteries, right? And this is a histogram of the data, right? So it tells you, like, you can see, looking at the histogram, that most of the batteries have a lifetime between 3 and 3.5, right? And not so many have lifetime between 1.5 and 2, or 4.5 and 5, right? So these bars, okay, by the way, these are densities, but you can also plot these in counts instead of the density, right? So the size of these bars tells you how frequent the lifetimes are. So the larger, the longer the bars, that means there are many batteries with lifetimes between these two, 3 and 3.5. If the bar is very short, like this or like this, that means there are not so many data points in this interval or in this interval, right? Okay, and the R command, for doing this plot is HIST open bracket X close bracket. Okay, so this command will produce a picture like this. Okay, and the next, I mean, there are many shapes possible for the histogram depending on the kind of data that you have, right? I mean, in this case, the shape kind of looks like kind of centered around this, right? But it may not be always like that. It can take all kinds of different shapes, right? So let me show you some possible shapes, like this shape. If the histogram looks something like this, right, where everything is perfectly symmetric, right? This is a symmetric, histogram, right, or distribution, because everything looks kind of roundabout symmetric around this point, all right? Okay. Whereas if you have something that looks like this, right, then this is skewed. Here you have a skewed is skewed to this side. You can also have the other way around, right? Okay. Right. So it's a skewed distribution or skewed histogram, right? Okay. And just to give you a picture, there are two kinds of skewness possible. Like, if you have, suppose, I'm not very good in drawing pictures, but I'll try my best. Suppose this is the data and this is your histogram. And suppose you have a histogram looking like this. Okay, right, and in this case, what you have is a distribution that is positively skewed. You should have a skewed a distribution of histogram looking like this. This is known as positively skewed distribution or histogram. Right. Whereas if it looks the other way around, right? So let me draw another picture here. So suppose it looks like, say, right, suppose it looks like this, right? In this case, the histogram or the distribution is known as negatively skewed, right? Right? Okay, so you can have two kinds of skewness depending on which way it goes, right? If it goes this way, it's positively skewed, this way is negatively skewed, right? Okay guys, so that this completes the video on graphical displays. And in the next video, I shall talk about normal distribution. I mean, you might have learned about the normal distribution in probability 1 or some other courses you took in previously. So anyway, I will talk about it in more detail in the next video.